And now we want to come to Dr. Johannes Gulden, head of the Institute for Renewable Energy Systems at the Stralsund University of Applied Science, which is also an ELMAR partner, will give us a lecture on the topic future requirements for charging infrastructure in marinas. Yeah, stay excited and thank you.
Thank you.
Yes, thank you as well. So I have a presentation that is very close to the presentation we just had. Since we are here all in the same room, we're just trying to mute everything hectically. And so within the ELMAR project, we also were working on a small infrastructure study in our region, and we analyzed the ports and the infrastructure. And I have a few slides on that, and we are quickly going to do that before the break because a lot of my slides were already in the talk we just had. So from our side, it's a few words about the infrastructure study that we did in the ELMAR project. So first of all, we looked at our region, we looked at the infrastructure that we have around here, and we said that we have to take our federal state of Mecklenburg-Vorpommern, which you see on the left, and divide it into different parts where we have other demands in the mobility. So there is this big purple part that is along the shore and also is connected to the back infrastructure on the inland. Then you have the big green part that is our island of Rügen. This is a big island which has a lot of infrastructure also. And then there is the two peninsulas which are shown here in blue. One of them is in dark blue, Fischland Das, along outside coastal line to the Baltic Sea. The same with the island of Usedom. And then the small orange region up there, that is the island of Hiddensee, a very small island. On one side you have the outward coastline to the Baltic Sea, and on the inside you have something which you could almost say is the same as the inland waters. And so we looked at our region and said, this is very interesting. This is where we need to see the actual infrastructure, and there we need to analyze that. And so we looked at the ports that we have available, and in there are different sizes. Okay, so we said we have a class 1 port, that is an industrial port, a seaport, ferry port, things that are big enough to support huge ships. They have a water depth of more than 1.80 meters, a very good port infrastructure, and it is very good for the big ships. And then we have base ports, we have stage ports, and we also have only ports of refugee, so emergency ports. And we looked at our region and said, look, there are, due to these different coastlines and due to these different regions, a lot of different approaches to the electromobility, which now gives us a shorter distance that we can travel, and other demands on how long you need to charge your boats or your ships. And we're mainly looking at boats in this infrastructure study. So it is necessary for us to see which distances do boats travel in our region. In addition to the different regions, we also have requirements which are probably going to give us the opportunity to have emission-free boats soon, because we have a lot of protected areas here in our region. Nature reservoirs where there is, right now it's only not allowed to go there, but soon probably these will also be emission controlled areas. Let's see how long politics takes till it is not allowed to go there anymore with a normal combustion engine boat. There are a lot of regions where right now you are not even allowed to go. So these are marked here in red. And if we are looking at the port of Barhöft, for example, and if you want to move out to the north, you have to travel a longer distance due to these protected areas. So you're not allowed to go the direct way, you are only allowed to go on a longer way, you have to take a small detour due to these protected areas. And we had to take this into account when we were analyzing the distances that are needed in our region to look at the charging infrastructure. And then we did a very similar approach to the talk we just saw. And so I can now basically flip very quickly through the next slides, because we also said, well, if we're looking at the charging infrastructure, we can orient at what is already happening in the automotive industry, because there they have all the charging infrastructure, it's all ready for the outside use, and we have either a waterproof normal plug that is used for the boats. We can use this. I mean, boats have been charging over many years already in small ports, right? This is nothing new to supply electricity to a boat if it is ashore. So all we need now is to look at different modes if we want to charge faster. And for this, we also said, let's look at the different charging infrastructures. So here, fast charging in AC with 20 kilowatts upwards. And then you just saw basically the same picture, right? The different charging methods and the different charging powers are all available. So we took all of this into account as well. We said we have mode 1 charging, which is okay for boats that lay there all night long. And most of the boats are not only laying there all night long, most of the boats are actually laying on the pier for many, many weeks. And then they just go for a fishing trip one afternoon. So Saturday afternoon is fishing time, and then the rest of the week the boat is just lying around and actually can charge on a very slow charger, right? So this is not a problem. We can work with these slow chargers in many of the applications. Only if people are taking longer trips, so if people are actually taking a long trip along the coast, hopping from one port to the other, then they are charging overnight. And then we need maybe faster charging powers, and sometimes mode 1 charging is not enough. Maybe we need to go to a mode 2 charger so that we can charge on all 3 phases if we have a bigger boat, to get more power into the boat quicker. Mode 3 charging has just been explained. It's basically just a bit more power. And then if we go to mode 4 charging with a DC charger, this is something that probably is responsible for a lot of power to put into a ship, I would say. I think DC charging for boats is not required unless you have a big enough boat that basically is already a ship. So if you are running on a big DC charger that is required, I don't think that we will see this in the small ports. I think this is something that we will see in the big ports, these class 1 ports that we were taking into our consideration when we were making the classification of the different ports. And so we said how to include these different charging modes. Similar to the cars, we have a wall box already available. I think the wall box is something that is not necessarily good for the boats. I mean, this is something if you have your own boat. And a lot of areas you have access to your own boat, there it works. But for the coast, for the ports, this is not suitable, because the wall box, I mean, this is for private use mainly. So there, it's probably a better idea to have a charging station, and it was just explained how that can be done in a small marina. Then how to access them in public or semi-public ways. So semi-public means you have to be part of the marina, so you are probably paying a certain fee that you are a part there, or you have totally public available charging stations, and there the problem is, of course, how to count how much electricity you are giving to someone, who's paying for that, how much does the electricity cost. And that brings us to something that was just explained as well in the previous talk. So who is playing which role in this entire thing, right? So we have the electromobilist, that's the person who's owning the boat, who's running the boat, or in the case of the car mobility, the person running the electric car. Then you have the landowner, the charge point operators, the mobility service provider, the e-roaming service provider, all of these people playing a certain role in this. And here we see on a quick picture once more showing how they are all interconnected, and who's running the boat and who's selling the electricity and who's paying which money to whom. So a lot of this is not actually running on the technical side, right? A lot of this is actually running on the financial side. So a lot of this is paperwork that has to be taken care of. So then we looked at the available infrastructure already at ports, right? And so here, small inland port in Neustrelitz, where we found there is already charging infrastructure available, especially this mode 1 charging is basically available in all the ports. And actually in more ports than there is infrastructure available for the conventional method. I mean, you can charge boats via an electric connection in more small marinas than you can bunker diesel or gasoline for your boat. So a lot of people are coming with canisters and bringing diesel or gasoline to their small boats, to their outboard motors, whereas basically every marina place has its own charging station. I mean, right now people are mainly running their refrigerators, are running their air conditioning or their TV set in their boats, but soon they can also charge their electric propulsion. So one of our conclusions was that electric mobility is very well available, and we can have the infrastructure in many ports already there. And one of the questions that was also just in the talk before is what is happening with many people coming there at the same time. So a lot of boats coming there at 6 p.m. maybe in the afternoon. All the boats are coming from their day trips, and you have this at the same time charging of many boats. And then we need the intelligent management of that, of which boat is going to charge when, and maybe we also again need to fill a few paperwork so that those who need to leave the port first in the next morning are going to maybe pay a higher price so that they get more charging power, or that they are first in the line to be charged. And these kind of things need to be solved. But I'm not worried about the actual charging. The question is also about the backbone of the marina. How well is it connected to the entire grid, right? These kind of things are all taken into account. And then we looked at the available motors. So what is available on the market today? What are the distances that you could travel with a boat on a size that is available and that is normally traveling here in our region? And you see here there are those very small solutions for 2 kilowatt power solutions where you can travel with a very small boat, but that is totally enough if you want to just go on a short fishing trips. I mean, as often you only go 1 or 2 kilometers away from the marina. That's where you bring out your fishing line, and then you're coming back after having a few beers and hopefully catching some fish. We all know fishing is not about the fish, it's about sitting on the boat and being relaxed. If you want to go longer distances or with bigger boats, you take the bigger solutions, which you see here on the right on this table, 33 kilowatts. This is where you can move a pretty big sailboat already, and you can go higher speeds, and you can travel longer distances. And if we look at the distances that are required, and that brings us back to actually analyzing here our region, what are the distances that we need to travel? So we said, well, maybe people are traveling along the outer coastline. As if you're traveling on the inner waterways, this is not a problem. These are only the long distances here, the long distance trips coming from all the way in the west, coming from Warnemünde, going all the way to Świnoujście on the Polish side. Then you are traveling the longest part. You see that on the east there is the 33 nautical miles traveling from Kreslin to Świnoujście. This is the longest trip that we found here. All other parts are shorter, and these can be traveled by the boats and by the motors that are available. So our conclusion mainly is that it is possible right now to go for electric propulsion in boats in our region, because we have a good enough network of ports, of small ports, where we are already equipped with an infrastructure to charge a boat overnight. And normally you are staying overnight. I mean, a lot of these ship people tend to get up very early, of course, very well, but then you're going for a sailing trip, and then you don't need the same amount of electricity when you're coming to the next harbor. So maybe if the wind was well, you're coming to the next harbor basically with a full battery, right? You don't need the charging power, and then everything is fine anyway. So if you're traveling along these outer coastlines, I think in our region you are just fine. The question now is, of course, if you're going to bigger boats and to ships, then if we still have the charging available, and that's why we looked at these charging times for small boats, 10 to 14 hours. That is okay, but for bigger ships, you don't have the time to stay in the harbor for such a long time. Then it's a different story, of course. So with that, I think maybe it is a bit more to what we just saw in the other talk. I think a lot of this was very similar, and I'm at the end for my presentation. I would be happy to take questions. I see one question already in the chat, and if there's others, I'm happy to take them as well. But the question that is there, I don't quite understand. So did you prove the actual available current values? You mean if we looked in the marinas, if these current values are available? I think if that is the question, then these high current values for the mode 2 and mode 3 chargers, there it's difficult. This is not available at every marina, of course, right? So the small marinas that we were looking at are okay with the mode 1 charging. So this is available, this is there, that's not a problem. There the current is there. If we are talking about especially then mode 4 charging, DC charging, this is basically nowhere. So no marina has a DC charger, but it's not required. That's what we found out. And the currents are, well, some marinas or some harbors, especially those class 1 or class 2 harbors, they have the high currents available as well. So that's not a problem. So then I got the remark, at present there are much bigger motors and you require more power. Yes, that's what I get. So you require more power if you want to go these long trips. If you want to go in one go. No. So if you want to take the entire trip in one go, of course you need a lot more battery capacity, right? So what we looked at is the port hopping, so really going from one port to the other port. If you want to go the entire trip, the entire coastline, then you would need a lot more battery power. And I think that is, with today's technology, not yet feasible. I guess you need a lot more energy in your boat then. Maybe go for hydrogen, right? Read our hydrogen study from the ELMAR project. But the trips that people normally take are really day trips, going from one port to the other. If you're taking a sailboat, where you can sometimes also take these long trips, you're sailing, you don't need much battery capacity, right? That's what I said. You're probably coming to the next port with a full battery and everything is fine. I hope that answers that question, and we can go into a coffee break. So I cannot really invite you to coffee and cake as we normally do if we would have been with the catering. I have a bit of coffee. I hope you have some coffee as well. We're going into a short break, but that's Mario's task to announce that. Thank you for your attention.
Thank you, Johannes. Thank you also for your lecture, for the answer questions, and for answering.
Can we have some questions?
Thank you and enjoy.
Can we have some questions?
Philip, hi. Questions
yes,
to Johannes or for organizational stuff?
To Johannes.
Johannes, is it possible?
Yeah, sure,
Maybe
of course. That's possible. No, I'm just switching the microphones because We've got a lot of technology here. Maybe we'll share a making of all of that and show you how many meters of cable we are using. No, I'm happy to take questions. How can I help you?
So I think the technique is
Okay.
Now Philip is not. Now there you go. Okay, Philip, go ahead.
Yeah, I just maybe not. That's not a question, but some also my experience with marinas. That can be a problem. That how you pay for the electricity in marinas. So mostly of the types of paying on marina is prepaid marina, and sometimes it is paying by coins, and that can be a problem if you would like to charge a lot of batteries in the marina, and you should keep many coins for that. So that's sometimes can be a problem with this infrastructure in marinas for the boats. That's the one thing. And the other thing is what you say, that hopefully if you have a good wind, then you wouldn't charge a battery in other harbor, but sometimes can be a problem if you don't have a good wind, but you have, for example, no wind, and then you have not enough energy in battery, and if the wind is not good, so in that direction, then you need more energy if you really need to, for example, go somewhere to some place to another, and then not enough energy for the waves and the wind, which is not from direction you would like to have. So that can be a problem. But the truth is what you say, that maybe it can be some steps for that we have, and especially in our region from Szczecin to Stralsund, that it can be for smaller boats which don't sail on the sea, so they make like small steps from the marina to the marina, and it's like not a seaside but kind of inland water, but with distances which are good for I think for electric boats, for electric yachts. So maybe even we can say our region is some really good place to start with that kind of electric boats with small distance, not with big waves like at the sea, and with infrastructure in marinas with electricity. So this is like what I would like only say, not maybe ask.
Okay. Yep. No, thank you, Philip, for this nice comment, because you're absolutely right. And so what we need now are basically electric boats, right? So the region is there, the infrastructure is there. You have a very good point if you say, of course, it doesn't make sense if we are now paying with coins, right? That doesn't work. I mean, you can't put plastic chips in just to keep charging your boat. So we need new modes of paying. That's why we were looking at this whole who's playing which role, right? You have the charge point operator and these kind of things. And in Germany, you have this entire big deal of who's allowed to sell electricity. I mean, you can't charge per kilowatt hour, because then you're selling electricity and you have all the burdens of someone who's selling electricity. You're an electrical provider then all of a sudden by German law. I mean, that might be different in other parts of the region. Let's discuss that maybe at some other time. That would be interesting to see how that is happening. And I just know that from the car industry for the electric cars, there they have these problems and how to do this. So some of them are saying, well, let's just sell the parking space then, right? So I'm not selling the electricity, I'm selling the parking space, and at the same time I give the electricity away, right? And so I give this as a constant value. It doesn't matter how much electricity you take. And so maybe we need to find new paying themes. And I kind of just touched the subject because it's an entire talk in itself on how these paying schemes might work in the future. I think it's not going to be the same way as we do right now in the marinas, because once people are going to charge batteries, and there was this nice comment in the chat about, and yes, our talk, my talk was only one company mentioned. There are other companies. It's not commercial, and we're not sponsored by Torqeedo. So of course there are other companies as well, and there are big batteries available, hundreds of kilowatt hours. And if you want to pay them, if you want to charge these batteries with the same price as you do charge, or if you run your refrigerator and your screen or whatever you're running in your boat right now, you are willing to pay a rather high price for electricity, but you're not willing to pay this price if you're charging 200 kilowatt hours battery. So that's not what's going to happen. So people need to find different ways of maybe having a different price for the charging of the boat, and another price if you have this fast charging, slow charging, and all of these things. I think that's an entire discussion in itself.
Thank you, Philip, for the question and for the comments, and Johannes too. So